Hello everybody, you all have realized that picture has got the power and computer graphics gives us the flexibility to create these pictures. In this lesson today, first we shall cover the basic building blocks which give us the power to create the pictures, and then go on to focus as to where these pictures can be outputted, namely the display device, where the picture can be displayed. In particular, we shall be concentrating on a video display unit, a typical VDU named CRT or cathode ray tube. Its terminologies and its technology shall be reviewed in this lesson. A real life picture is a complex entity. It may have motion, color, shades, complex contours and varying dimensions. Let's simplify the whole picture into simple terms. First, let's consider only a static picture. Therefore, motion is eliminated. Then we eliminate or not consider the colors and shades. Let's first concentrate on its contours, its size and shape. So, the object could be a three-dimension. It could be regular or irregular. For example, take a box, it's a regular shape, or it could be having different contours, different height, width and depth, like say for example our human body. How do we create or how do we show this three-dimensional body on the screen? For a moment, take a break at this point and let me introduce you to a term called primitive. So, what is a primitive? A primitive has different meanings in different contexts. In our context, it means the basic building block. Say I would like to create the picture of a forest. The tree becomes a primitive. That's because a collection of trees make the forest, and for a tree, a trunk, a branch, leaves, fruit, they become the primitives for the picture called tree. So, if I am armed with the primitives called the leaf, fruit, the branch and the trunk, I will be in a position by varying its shape and size create different trees and a group of trees and so a forest. So, in our context, for a three-dimensional object, what is a primitive? The primitive is a dot, a point, because many of them will join together to form a line, and different line segments form curves. Lines and curves can form surfaces, and when you join the surfaces, I will get an object, and the object is our three-dimensional object. Therefore, in order to create a three-dimensional object, first I should know as to how I can represent the dot. Then I can go on and creating the other primitives such as line segments, curves, surfaces, etc. So, once we have understood that a simple dot can create the most complicated three-dimensional object, we go on to see where this dot can be displayed. The typical display devices are plotters and printers and video display units or VDUs. Plotters and printers you have been seeing in every office. The biggest advantage of a plotter or a printer is it is permanent, good for storage, but it is time consuming, and one notable limitation is whenever you have a change in the picture, a new output is required to be taken, which takes time and effort. We shall be covering these devices in detail in later part of our lessons. So, now we move on to the next device called video display unit or VDU. A typical example of the video display unit is the computer monitor or screen. They come in all sorts of sizes and shapes. One such monitor you are in fact staring into is the screen of this laptop. Many technologies are available for making these screens or monitors. We shall however concentrate on a time-tested and rugged system called cathode ray tube, or in short CRT. CRT is a vacuum-filled tube basically consisting of three parts. 1. An electron gun. 2. A yoke or deflection system. And 3. A phosphor-coated screen. Electron gun. When a potential is applied to the electron gun, the electrons are generated, or a beam is generated, and that beam is directed by the yoke or the deflection system to the spot where we require on the screen. When the electron beam strikes a spot on the phosphor coated screen, the phosphor emits a glow, and the glow is what we see as a dot. So in short, the CRT relies on generating an electron beam, directing it to a spot on the screen, and the screen displays the glow as a dot to be seen by us as a final result. In addition, the CRT has a few more components: the focusing and accelerating system, which will ensure that the electron beam is sufficient velocity and does not scatter and focuses on the screen. But here we have to address a problem. The glow remains as long as the beam is on. The glow fades off as soon as the beam is switched off. But the phosphor has got certain property of retaining glow for a short duration. This is called persistence. Persistence is the duration through which the glow remains even when the beam is switched off. Normally the limit is taken as 60% of its original intensity. The persistence of different materials vary. They may be as low as few microseconds to as high as 1 second. But now we come to two different problems. How do we make the glow to appear permanently, or as long as we want the image to be shown? And the second problem is, how do we get different colors? Let's first address the second problem. The answer lies on the phosphor coating. The phosphor coating emits a light at a typical frequency depending on its nature. So different phosphor coatings will give different colors. We shall cover it in more detail in our subsequent lesson. Let's come back to the first problem as to how to get over the problem of persistence, or how to ensure that the dot glows as long as we want it. One simple answer is, if you require more dots to glow, keep that many guns. So as long as the guns are on, the dots are on. But this solution is neither practicable nor efficient. In reality, we have just one electron gun, but many dots. So we get over this problem by a simple trick. We refresh the dot, or keep lighting up the dot by hitting it through the electron beam repeatedly. And the rate at which it is done is so fast, the human eye thinks that the dot is glowing permanently. So this refreshment gets over the problem of persistence of the phosphor coating.